मीठा होता है। थैंक यू फॉर टेलिंग मी। थैंक यू फॉर टेलिंग मी कि सब्र का फल मीठा होता है, मुझे तो पता ही नहीं था है। सर लेट्स स्टार्ट, लेट्स स्टार्ट। ओके, कैन आई हैव अ गुची इन द चैट बॉक्स? लेट्स स्टार्ट विद लेक्चर नंबर dos. Yes, lecture number dos, tres, cuatro, cinco, mucho, prucho. I'm just so tired, man. I just wanna jump off. No, I'm joking. I'm joking. Please, I'm joking. Please, please, please. Okay, let's write lecture number dos. Oh, what a pathetic color. Lecture number dos. So we started off with our beautiful alkenes. We started off with our beautiful alkenes, and we said that alkenes are saturated hydrocarbons. And then we understood the meaning of saturated, because saturated were compounds. Compounds were said to be saturated when there was only a carbon carbon single bond. Please, it's important to write only, right? So carbon carbon single bonds only. That's what we mean by saturated. And hydrocarbon literally means that those compounds in which, see, hydrocarbon, those compounds in which you have hydrogen and carbon atoms only. Only is the keyword, right? No other atoms. And this was actually very, very helpful for us in drawing the structures of alkenes. But before we drew the structures of alkenes last time, we also looked into how to name these alkenes. So we had our beautiful, beautiful nomenclature with which we replaced this prefix alk, right? So from our understanding of IUPAC, which was the International Union of Applied and Physical Chemistry, they said that the alk bit is going to be replaced with the prefix, which is going to represent the number of carbons. So if I talk about a 3 carbon alkane, if I talk about a 3 carbon alkane, 3 carbon literally stands for prop, right? So the alk bit is going to be replaced with prop. That's going to be the prefix, and the suffix is going to be the ane, which is going to drop down, right? And this name is going to tell you two things. I'm just giving you a recap. This name is going to get tell you two things. This name is telling you the number of carbons. The prop is literally telling you the number of carbons, which is 3, and the ane is telling you the family of organic compounds that this belongs to, which is an alkane. And alkanes are saturated hydrocarbons. So if I talk about propane, prop literally means 3 carbons, but because alkanes are saturated, this would mean that all the carbons would have single bonds between each other. And because they are hydrocarbons, all the other bonds that the carbon is going to make is going to obviously be with hydrogen. I'm not writing H, but it's understood that this tick literally represents H. You have to write all the H's in the paper, right? Sir, how do you know how many bonds carbon is going to make with all the H's? Oh, you dumbo, you know that carbon has already made one bond, and in totality, carbon can only make 4 bonds in total. So if it's made one bond right here, it's going to make 3 more bonds. If this carbon has already made 2 bonds, it can make 2 more bonds. Sir, you said saturated means single bonds. Here, carbon has made 2 bonds. Oh, you dumbo, there are 2 bonds, but they're both single bonds. It's not a double bond between a carbon and carbon atom, right? So you understand that there are more bonds that carbon can make with all the other carbon atoms, but it's always going to be single bonds, right? And this type of representation was called the displayed formula. Why was it called the displayed formula? Because you were displaying everything. Literally, you were showing all the atoms. We show all atoms or all bonds between all atoms, right? That's what I'm literally showing. I'm showing all bonds between all atoms. Done, sir. Now, there's another type of representation called the structural formula. There's another type of representation called the structural formula. Before we go into the structural formula, I want you guys to draw the displayed formula. I want you guys to draw the displayed formula for a 3 carbon alkane, a 4 carbon alkane, a 5 carbon alkane, a 6 carbon alkane, a 2 carbon alkane, and a 1 carbon alkane. Can everybody draw it? Yes, come on. So a 3 carbon alkane is propane. We literally drew this before. We know that it's a 3 carbon alkane, and alkanes are saturated, and obviously they are hydrocarbons. So it's a saturated hydrocarbon. Boom shakalaka. So butane is obviously meth ethprobute. Butane means 4 carbons, so it's going to be a saturated hydrocarbon. That's what a butane is. How do you know it's an alkane? The A and E is literally telling you that it belongs to the family of alkane. Pentane. Pent means 5 carbons. All the carbons are going to have single bonds between each other because it's a saturated compound, and because it's hydrocarbon, all the other bonds that the carbon is going to make are obviously going to be with the hydrogen atoms. Again, hexane, 1, 2, 3, 4, 5, 6, 6, sir, 6, 6, and then all the other bonds are going to be with hydrogen. And then you have ethane. and obviously it's a saturated hydrocarbon. Now I know that you guys can draw it, right? And this is obviously methane, which is right here. That's the beauty. These were all the displayed structures, right? The displayed formula. Now, what do we mean by a structural formula? A structural formula shows each unit, it shows each unit in the structure, it shows each unit in the structure, but no bonds, but no bonds except a double bond or a triple bond. It shows each unit in a structure but no bonds except a double bond and a triple bond. अब सवाल पैदा होता है सर इसका मतलब क्या है? What in the world do you mean by this? It's a very 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 easy way to write the structural formula. How do we write the structural formula and how do we go from a displayed formula into a structural formula? Basically what happened was that scientists were fed up of drawing these atoms all over again, right? In displayed formula you have to write all the atoms, you have to show all the bonds between all the atoms, and it takes a lot of time, right? So what they did was they came up with an easier way. They said, each carbon is going to be considered, each carbon and all the bonds that it makes, it's going to be considered as a single unit. So each carbon and all the bond that it makes is going to be considered as a single unit. So what am I going to do? I'm going to take my pencil right here or the highlighter right here. I'm going to highlight this carbon right here. I'm going to highlight this carbon and the bonds that it makes, and I'm going to highlight this carbon and the bonds that it makes. Can you please tell me this carbon has made how many bonds with how many bonds? This carbon has made how many bonds with other atoms other than carbon? Other than carbon, how many bonds has it made? Obviously, it has made 4 bonds, but other than carbon, how many bonds has it made? It has made 3 bonds. So I can say the first carbon has made 3 bonds with hydrogen. So it's going to be CH3. The second carbon has made 2 bonds with hydrogen. So that's CH2, sir. And the third carbon has made 3 bonds. The third carbon has made 3 bonds with hydrogens, and that's literally the structural formula. So what do we do in the structural formula? We show each unit in the structure, but we don't show any bonds, except if there is a double bond or a triple bond. If there was a double bond right here, I would have shown the double bond right here. If there was a triple bond right here, I would have literally shown the triple bond right here. But because there's no triple bonds or double bonds, there are only single bonds, I'm not going to show any single bonds whatsoever. I'll just write the carbon and I'll write all the bonds that it has made other than the other carbon, right? So this carbon has made 3 bonds, boom shakalaka. This carbon has made 2 bonds with hydrogen, boom shakalaka. This carbon has made 3 bonds with hydrogen, boom shakalaka. That's what we mean by showing each unit in the structure. This is a separate unit. This is a separate unit. This is a separate unit. Now, I want you guys to write the structural formula for all of these beauties. I want you guys to write the structural formula for all of these beauties. Okay, come on. CH3, CH2, CH2, CH3. Sir, so easy. CH3, CH2, CH2, CH3. Boom shakalaka. Sir, now look at this one. Look at this one. CH3, CH2, 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 CH3. How easy? CH3, CH2, 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 CH3. That's how literally you could draw right the structural formula. कम ऑन कम ऑन कम ऑन कम ऑन कम ऑन आगे 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 कार्बन को देखिए कितने बॉन्ड्स बनाए 3 अदर देन कार्बन कार्बन को देखिए कितने बॉन्ड्स बनाए 2 2 2 2 3 बूम शाकलाका सो इट्स अ कार्बन बॉन्डेड टू 3 हाइड्रोजन्स इट्स अ कार्बन बॉन्डेड टू 2 हाइड्रोजन्स बॉन्डेड टू 2 हाइड्रोजन्स बॉन्डेड टू 2 हाइड्रोजन्स बॉन्डेड टू 2 हाइड्रोजन्स and bonded to 3 hydrogens. And sometimes what the examiner can do is instead of writing so many CH2s, instead of writing CH2 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 CH2, how many CH2s are there? There are 4 CH2. So sometimes what the examiner can do, you guys can write it like this, but sometimes what the examiner does in the MCQs to confuse you, he writes CH3 here and he writes CH3 here, and what he does is he combines all the CH2. So what he does is he says CH2, and how many CH2s are there? There are 6 CH2s. So don't be confused by this. It's CH3 and 6 CH2s means, oh sorry, 4 CH2s. Is CH2, how many CH2s are there? 4, right? So this literally means this bracket into 4 means that there are 4 CH2 units. CH2, 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 CH2. There are 4 units. CH3, CH2, 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 and then you have CH3. Done? Can you guys write the structural formula for this beauty? This carbon is bonded to 3 hydrogens. This carbon is bonded to 3 hydrogens. Done? So carbon is bonded to 3 hydrogens and carbon is bonded to 3 hydrogens. Sir, this carbon is bonded to 4 hydrogens. Sir, this carbon is bonded to 4 hydrogens. Done, sir. Done, sir. How easy? How easy? That's literally the structural formula. So what we do is we treat each carbons and the bonds that it makes separately. Treat each carbon and the bonds that it makes separately. Now, once we have the structural formula, I want you guys to write the displayed formula. I want you guys to write this. So I'm gonna give you now a quick chem check. I'm gonna give you guys the structural formula, and you guys have to go from the structural formula into the displayed formula. Please come on. CH3, CH2, CH2, CH3. Sir, displayed formula बनाने हैं. CH3, CH2, 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 CH3. Come on, come on, come on, come on. CH4, CH3, 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 CH2, CH3. And last but not least, CH3, CH2 times it by 5 and then CH3. चलिए जी बनाना शुरू कर दें. Sir, why don't they write it in combined form like plus? No, no, that's something else, Amna. That's something else. गोली मारे कंबाइंड फॉर्म को हम बाद में देखते हैं ना कि उसको क्या कहते हैं ना. अच्छा जी, ड्रॉ द डिस्प्लेड फॉर्मूला प्लीज नाउ. Come on, let's go from the structural formula to the displayed formula. Let's go, let's go, let's go. Come on. So now the way you do it is you literally draw these units. So what you do is if this is a CH3, CH2, CH2, CH3, what I'm going to do is I'm not going to draw the other bonds. And what I'm going to do is I'm going to draw the carbon and I'm going to draw the bonds that it makes with the hydrogen. Look at this beauty. Draw the carbon, draw the bonds that it makes. Draw the carbon, draw the bonds that it makes. Draw the carbon, draw the bonds that it makes. Draw the carbon, draw the bonds that it makes. Now, it's very, 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 very common sense. You understand that this carbon was bonded to three hydrogens and this carbon was bonded to two hydrogens. So what should be the bond between these two? What should be the bond between these two? Obviously, carbon has made three bonds. How many more bonds can I make? One. So you understand that this is a single bond, that's a single bond, that's a single bond. That's how you go back from a structural formula into the displayed formula. What do? You literally just draw these units and then in the end complete the carbon bonds. Draw these units as they are. See, it's a CH3 beauty, that's a CH2 beauty, that's a CH2 beauty, that's a CH2 beauty, that's a CH2 beauty, and that's a CH3 beauty. Now look at this beauty. There are three carbon atoms. It obviously has to complete its bond, so it's going to make one bond. Now carbon has made three bonds. It can make one more bond, one more bond, one more bond, one more bond. Boom shakalaka, boom shakalaka. CH4, carbon bonded to four hydrogens. CH3 and CH3. Now, what should be the bond between these two carbon atoms? What I'm doing is I'm teaching you guys an easier way and a more logical way to go back from the structural formula into the displayed formula. So it's a CH3 atom, it's a CH3 molecule, CH3 molecule. What should be the bond right here? Obviously, this carbon has made three bonds. This carbon has made three bonds. They can only make one more bond because a carbon can make two bonds, four bonds in total. Uh, Ajay ji, sir, CH3, CH2 and CH3. No, I did not get a haircut. Kya ho gaya? I shaved. Done. CH3. And now it's saying CH2 times by 5. What does this mean? That there are 5 CH2, 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 and CH2. Done, sir. 5 CH2s बना लिए. 1, 2, 3, 4, 5. That was it. That's what it means, right? And then you have CH3. Done, sir. Then you just draw the bonds. And these are all my beautiful, beautiful, beautiful structural formulas. And now these are all my displayed formulas. You could easily go from a structural formula into the displayed formula. But what your examiner does is the examiner says, write. Now, this is the keyword. The examiner says, write the structural formula of maybe, like propane. Write the structural formula of propane. Have you written it somewhere? Chalo, butane kar dein. Write the structural formula of butane. Done, sir. Oh, butane. Done. So that's CH3, CH2, CH2, and CH3. Done. You could first draw the displayed formula for yourself quickly, and then you could just condense it. It's just a condensed form of the displayed formula. You could literally condense it for yourself. But sometimes the examiner says, hey, sir, please draw the displayed formula for butane. Then what am I going to do? Then what am I going to do? Obviously, I'm going to literally draw this beauty right here. That's the displayed formula for butane. But sometimes the examiner says draw the structural formula for butane. Now what am I going to do? Draw the structural formula literally means draw the structure. Yes, Harim. Draw the structural formula literally means draw the displayed formula. See, when he's saying draw it, you draw it for him. You draw this beauty for him. So if he says draw the structural formula or draw the displayed formula, they literally both mean the same things. But Both are same. But if the examiner is, because you're drawing, right? You're drawing, you're showing all the bonds and whatnot. But if it says write the structural formula, then you strictly have to write this beauty right here, right? Then there's a third type of formula called the molecular formula. So there's a third type of formula called the molecular formula. Sir, what is meant by the molecular formula? The molecular formula is the number and type of different atoms in one molecule or in a molecule, right? Done, sir. The number and type of different atoms in one molecule. Sir, what does this mean? This means, for example, I say, can you guys draw the displayed formula? Can you guys draw the displayed formula and structural formula for the first 5 alkenes? Come on, मैं साथ साथ ये प्रैक्टिस करवा रहा हूँ, यही पेपर में यही सवाल हैं सारे, शाबाश. Displayed formula and structural formula for the first 5 alkenes. Can somebody draw it, please? Let's draw it. Sir, methane, obviously, we've drawn it like a gillion times, a bajillion times, so I'm going to quickly draw it. That's the displayed formula. It's a saturated hydrocarbon, saturated hydrocarbon, saturated hydrocarbon. And these are the first 5 alkenes. Huh? Methane, ethane, propane and butane and pentane. Done, sir. This is literally the displayed formula. Then I ask you to draw the structural formula, please. So can you guys draw the structural or write the structural formula? Not draw, because draw the structural formula would mean the same thing, right? So write the structural formula. That's CH4, that's CH3, CH3, beauty, that's CH3, CH2, CH3, yes, beauty, beauty, CH3, CH2, CH2, CH3. I hope that everybody knows why I'm writing this. This is CH3, CH2, CH2, CH3. That's why I'm writing it very, very quickly. And then the last one is CH3, CH2, 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 CH3. That's I'm writing it. Done, sir. So this was the structural formula. Now I want you guys to write the molecular formula. How do you write the molecular formula? How do you write the molecular formula, sir? Pretty easy. What did I say a molecular formula is? See, the definition in itself will tell you how to write it. If I'm saying write the molecular formula, is going to be the number and type of different atoms in one molecule. Can you guys tell me what two type of atoms do you have? What two type of atoms do you have in methane, ethane, propane, butane, pentane, hexane? What are the two type of atoms? Type का मतलब है मुख्तलिफ. What are the two type of atoms? So the two type of atoms are carbon atoms and hydrogen atoms. So can I say, sir, you have a carbon atom and you have a hydrogen atom? Can I say you have a carbon atom and you have a hydrogen atom? Can I say that, sir? Can I say that you have a carbon atom and a hydrogen atom, sir? Now, what is the molecular formula? It's the number and type of different atoms. I first of all looked into the type of different atoms. The type of different atoms were two. You had a carbon atom and you had a hydrogen atom here. Now, what's the number? What's the number? What's the number, sir? You know that carbon is one. You don't write anything when it's one. So carbon is one. And sir, how many hydrogens do you have? Four. So you'll count the number of hydrogens. You'll count all the different type of atoms, and then you're gonna count the number of those different type of atoms, and the number is going to be written as the subscript. Subscript क्या होता है? Sir, x की power 2. This power 2 is called superscript, and x की base 2, this is called subscript. This is superscript, this is called subscript in English, right? It's English. So what I'm going to do is I'm going to count the hydrogens. There are 4 hydrogens, and I'm going to write it as the subscript. Sir, the molecular formula is CH4. Now, let's write the molecular formula for ethane. Look at this beauty. You have 2 carbons and you have 6 hydrogens. So I'm going to say, sir, that the different type of atoms are C and H. And what is the number? You have 2 carbons and 6 hydrogens. Beauty. So now let's count this. Come on. You have 3 carbons, and now you have how many hydrogens? You have 2 type of atoms. First, you have 2 type of atoms. One is C and one is H. And how many C's do you have? 3. How many H's do you have, sir? 8. Beauty. Then count this. You have 4 C's here, and how many H's do you have? 10. And then you have 5 C's here, and how many H's do you have? 12. This is literally what a molecular formula is. See, the molecular formula, even when you write it, it is going to tell you the definition. याद रखिएगा, यही definition आनी पेपर में और यही लिखना है. अपने से अगर टर्नेली मानी ना तो मार्क कटेगा. मैं बता रहा हूँ, मजाक नहीं कर रहा. What you need to do is you need to go to your syllabus and write control F and then put define. Wherever define is written in your syllabus, you have to define it like that. I got an A star in A2 in A2 physics just because of doing that. I studied only 7 days for physics, but I knew that wherever the syllabus says define, I have to write the exact definition, and there's a concept behind it. Concept behind this exact definition is what? That it's the different type of atoms, and then you just sum it up, sum the number of it, and write it as the subscript. Done, sir. So these are all your markers. Once the examiner asks the question in an MCQ, and the examiner says, can the molecular formula and the structural formula be the same? Can the molecular formula and the structural formula be the same for any atom, any molecule whatsoever? Can the molecular and structural formula be same? So many students said no, 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 and those dumbos didn't even bother looking at this. They didn't even bother. They didn't even bother looking at this, that the structural formula and the molecular formula can be same. Look at methane. It's right in front of you. CH4 is the structural formula and it's also the molecular formula. So as so many students said no without even looking at it. यार थोड़ा सा दिमाग इस्तेमाल करना होता है, ठीक है जी. सो दैट इज आर ब्यूटीफुल मोलेकुलर फार्मूला, राइट. और हमारे कोर्स में हम जब मोलेकुलर फार्मूला लिखते हैं ना, सॉरी, जब हम मोलेकुलर फार्मूला हमारे कोर्स में लिखते हैं ना, हमारे कोर्स में, तो हम सिर्फ जो एल्कोहल्स हैं उसमें हम OH सेपरेटली लिखते हैं और कार्बोक्सिलिक एसिड में COOH सेपरेट लिखते हैं. ये क्या भला है, ये आगे जाके आपको पता लगेगा कि मैं ये क्या करूं. बस फिलहाल अपने साथ लिख लेंगे कि दिस इज ऑल्सो रिटन सेपरेटली है. ये हम इसको सेपरेटली शो करते हैं. आगे जाके आपको मैं सिखा दूंगा कि इसको सेपरेटली क्यों क्यों लिखा जाता है, ठीक है जी. अच्छा, आई हैव अ क्वेश्चन. Do you know what empirical formula is? You've already studied this. You've already studied empirical formula in moles. What is meant by empirical formula? Empirical formula is the simplest whole number ratio of different atoms and or ions in a compound. It's the simplest whole number ratio of different atoms or ions in a compound, right? And what you need to, I'll write it even, is the simplest whole number ratio of different atoms or ions in a compound. हाँ? अच्छा, मेरे एक सवाल है. What is the empirical formula of C5H12? C5H12. What's the empirical formula for C5H12? It's literally the same because it can no longer be simplified. How can 5 and 12 be simplified to give you a whole number? It can't. It can't. It's 5 and 12. It can't further be simplified, right? But if I take C4H10, that's the molecular formula, C4H10. Can I further simplify it? Yes. I notice that 4 and 10 both are divisible by 2. So if I take 4 and 10 and I divide this beauty by 2, you get 2 ratio 5. So if I talk about the empirical formula of C4H10, that's going to be C2H5. That's going to be its empirical formula. Which one is more useful? Is empirical formula more useful or is molecular formula more useful? Oh, you dumbos, no, no, no. Empirical formula is not more useful. Molecular formula is more useful because it gives you more information. It actually tells you the number of atoms and ions or ions in a compound. It is actually telling you the exact number of things. It's giving you more information. It's more useful. It's actually what's happening in reality. Empirical formula is just a ratio between the two things, right? So molecular formula is much, 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 much more useful than the empirical formula, right? And once the examiner asked in the MCQ paper and he said, sir, can empirical formula and molecular formula be the same? A lot of dumbos said no. A lot of dumbos said no. Oh यार, आपके सामने लिखा हुआ है C5H12 is the molecular formula, C2H5 is the empirical formula. They can be same for certain molecules. CH4, that's the molecular formula, and CH4 is the empirical formula as well. So please, 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 yes, they will ask about empirical formula. You've already studied this in Moses stoichiometry. Sir, if in structural formula double or triple bond हो, फिर इंशाल्लाह आगे जाके पढ़ेंगे, सब कुछ पढ़ेंगे. Then scientists said that, if I want to write the molecular formula of decane, how will I write the molecular formula of decane? So what our students did was they said, oh, decane or decane, your beautiful decane right here, dec means 10 and it's an alkene. So I'm going to first do what? I'm going to draw 10 carbons. I'm going to draw 10 carbons. How many carbons are these? 1, 2, 3, 4, 5, 6, 7, 8, 9. 10. So they said we are going to draw 10 carbons and then we're going to complete all the bonds because it's a saturated hydrocarbons. And then what we are going to do is we're going to write the molecular formula. For writing the molecular formula, we have to check out the different type of atoms, which is C and H. And then what I'm going to do is I'm going to count all the C's, which is 10. And then I'm going to count all the H's, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 22. So students, it's going to take a lot of time for you guys, right? It's going to take a lot of time. Scientists said, okay, if you're so smart, write the molecular formula of an alkane which has 100 carbons. So what our students started to do was, or what science students started to do was, they started to draw 100 carbons, and then they started to draw all the hydrogen atoms, and then they used to count the carbons, count the hydrogens, and write the molecular formula, because they had this in their brain that molecular formula is what is the number and type of different atoms in one molecule or in a molecule. But scientists said, oh, you dumbos, there is a beautiful trend that I could show you which would help you figure out the molecular formula of an alkane with even 100 carbons very, very easily. We said, how is that possible? Scientists said, sir, you've written these molecular formulas right here, right? You've written the molecular formulas right here. So what I'm going to do is I'm just going to copy them. I'm going to say, sir, methane, ethane, propane, butane, pentane, hexane, right? So methane had a molecular formula of CH4, ethane had a molecular formula of C2H6, propane is C3H8, butane is C4H10, pentane is C5H12, hexane is C6H14. And how do I know it? I've literally shown it to you guys right here. CH4, C2H6, C3H8, C4H10, C5H12. And what they said was, let's just focus a little. Let's just focus a little and look at these molecules. Can we not see that every time you jump one carbon, every time you jump carbon, there's an increase in carbon, there's an increase in carbon, and how many hydrogens are increases? How many hydrogens are increasing? So there's an increase in one carbon. For every increase in one carbon, there are two increases in hydrogen, right? So I can say, sir, every time you jump a carbon, there's an increase in one carbon, and then there's an increase in two hydrogens, increase in one carbon and increase in two hydrogens, increase in one carbon and increase in two carbons. So what they noticed was, they noticed this beautiful increase, and then what they noticed was that if I look at this formula right here, C3H8, if I look at this formula right here, C3H8 and C4H10 and C5H12, what they noticed was, whatever the number of carbons are, hydrogens are twice the number of that and plus 2. Whatever the number of carbons are, hydrogens are twice the number of that plus 2. Sir, what does this mean? Sir, you have 3 carbons here. Hydrogens are 3 times 2, 3 times the number, 2 times the number of carbons. So I can say, sir, if you have 3 carbons, hydrogens will be 2 times the number of carbons plus 2. If I have 4 carbons, hydrogens are 2 times the number of carbons plus 2. And look at this beauty. 3 carbons, you have 2 times the number of carbons, which is 6, plus 2, that's 8. 4 carbons, you have 2 times the number of carbons, which is 8 plus 2, that gives you 10. Sir, whenever you have carbons, whatever number of carbons you have, hydrogens are twice the number of that plus 2. So if you have 5 carbons, hydrogen will be twice the number of that, which is 2 times 5 plus 2. And they said, sir, this is a very beautiful thing we can derive. If you have any number of carbons, and they said, sir, the number of carbons, I'm going to call it n. Hydrogens will be twice the number of carbons, which in this case is n. So I can say hydrogens will be twice the number of n. And what happens? This plus 2 drops down. This plus 2 drops down. So for any number of carbons, hydrogens will be twice the number of that plus 2. And this beauty is called the general formula. So general formula is nothing new. It's literally, what is meant by the general formula? It's literally the molecular formula in terms of n. In terms of n, where n is the number of carbons. N literally is the number of carbons, where n is the number of carbons. तो अब साइंटिस्ट ने कहा, सर हमें प्रूफ करके दें कि ये हर जगह फिट होता है, बिल्कुल, फॉर एवरी सिंगल एल्केन दिस इज गोना फिट. लुक एट दिस ब्यूटी. सर CH4 carbon is 1, hydrogens is twice the number of 1 plus 2, twice the number of carbons plus 2, so 2 times 1 is 2 plus 2, that's 4. It literally proves it, it fits it. Sir, if you have 2 carbons, hydrogens will be twice the number of that plus 2. If you have 3 carbons, hydrogens will be twice the number of that plus 2. Literally, it's fitting the general formula. it's the general formula is being fitted beautifully. So if you have four carbons, hydrogens will be twice the number of that plus two. Literally, that's 10. If you have five carbons for an alkene, hydrogens will be twice the number of that plus two. That's how easy it is, sir. So what they understood was, if I want you guys to write the molecular formula for an alkene with 50 carbons, what is the molecular formula going to be? Instead of drawing all the 50 carbons and writing all the hydrogens, what can you do? You could say, sir, if it's an alkene with 50 carbons, we know that for alkenes, it's gonna literally fit the general formula, which is what? If you have 50 carbons, hydrogens will be twice the number of that, which is 100 plus 2, which is 102. Done, sir. Now you guys need to write the alkanes with 30, the molecular formula of alkanes with 30, 25, 12, and 16 carbons. Come on. You know that whenever you have alkenes, and if you want to write the molecular formula, you're going to write it how? How are you going to write the molecular formula? So you know that the general formula for alkenes is CnH2n plus 2, which means what? If you have n number of carbons, hydrogens will be twice the number of that plus 2. If you have 10 carbons, hydrogen will be twice the number of that plus 2. If you have 50 carbons for an alkene, it's going to be twice the number of that plus 2. If you have 100 carbons, it's going to be twice the number of that plus 2. Chaman, 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 chabash. So C30, sir, hydrogens will be twice the number of that. That's 60 plus 2, that's 62. Sir, C25, hydrogen will be twice the number of that, which is 50 plus 2, that's 52. Sir, C12H, hydrogen will be twice the number of that, which is 24 plus 2, 26. Sir, C16H, hydrogen will be twice the number of that plus 2. 32 plus 2 is 34. Sir, that's how beauty it is. Okay, okay, okay. That's the beauty of chemistry. Now, I want you guys to tell me, is this an alkene? Yes, no. Is this an alkene? Anji, is this an alkene? Everybody's saying yes. Why? How do you know it's an alkene? Yes. अब यस सबको पता है, लेकिन वाई का जवाब जब एग्जामिनर पूछता है ना, तो सारे बस गूंगे बैठ जाते हैं. कम ऑन शाबाश. वाई? It's not about it being a hydrocarbon. It's not about it being a hydrocarbon. It's not about it being saturated. How can you tell me from the formula that it's an alkene? You all looked at the formula. Did you see the single bonds being made? Did you see that all it was? Oh, it's not just a hydrocarbon. It's not just a hydrocarbon which is going to tell you that it's an alkene. It must be saturated. It must be hydrocarbon. Can you see that it's saturated by just looking at this formula, or do you have to draw it for it? You have to draw it for it. So I just want to ask you, how is this an alkane by just looking at the molecular formula? How did you just understand it's an alkane? हवा में कह दिया alkane है, फिर बनाए saturated hydrocarbon कहने के लिए तो बनाना पड़ेगा ना आपको, proof करना पड़ेगा. How did you understand? You understood it because it literally fits the general formula. जितने carbons and hydrogens are twice the number of that plus 2. So what you realize is it is an alkane. Why? Because when I look at this molecular formula, hydrogens, it fits the general formula for alkenes. It fits the general formula for alkenes, which is, I have to tell the examiner, which is CnH2n plus 2, and you have to fit it for him. दो कार्बन हैं, हाइड्रोजन दो टाइम्स दो प्लस दो, दैट्स फिट राइट हियर. ये 2 मार्क का सवाल आता है. लिटरली ये 2 मार्क का सवाल है. तो जो बच्चा कहता है ओ इट्स सैचुरेटेड हाइड्रोकार्बन, ओ ये वो एग्जामिनर कहता है भाई मैं पागल हूं, ये इधर देख के आप कह रहे हो सैचुरेटेड है, फिर बना के दो मुझे. तो भाई अकल इस्तेमाल करें, जो सवाल है उस मुताबिक जवाब दे. अब मुझे आप बताएं. नाउ यू गाइस टेल मी, C3H8, इज दिस एन एल्केन? इज C3H8 एन एल्केन? अच्छा, इसका नाम क्या था? C2H6 का नाम क्या है? इट्स ईथेन ऑब्वियसली. इट्स ईथेन. हाँ. अच्छा, C3H8, is this an alkene? C3H8, is this an alkene? Is this an alkene? Absolutely it is. Yes, sir, it is. Because if I look at the molecular formula, the number of hydrogens are twice the number of carbons. So 2 times 3 plus 2, that literally equates to 8. That literally equates to 8. So yes, it's an alkene. And which alkene is it? It's propane. But you have to tell the examiner why. Because it fits the general formula of an alkene. It fits the general formula for an alkene, which is CnH2n plus 2. And you will literally show the examiner the fitting you will show the examiner the fitting right here. C3 है तो H2 times 3 plus 2 है. सर खुश हो जाओ एग्जामिनर. अच्छा, मेरा एक सवाल है. C7H14, is this an alkene? Why? अच्छा, देखते ही साथ सारे कह रहे हैं नो 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 नो, व्हाई इज दिस नॉट एन एल्केन? हाँ जी, ये क्यों एल्केन नहीं? हाँ जी, करेक्ट करेक्ट, शाबाश 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 शाबाश, गुड 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 गुड, शाबाश। इसको थोड़ा ऐसे कर देते हैं। So why is this not an alkene? Because it literally, if it were an alkene, it should have had the formula for. If it were if it were an alkene, अच्छा अगर ये एक alkene होता तो फिर क्या होता? कौन सा alkene होता? If it was an alkene, you know that the hydrogens would be twice the number of carbon, which is 14 plus 2. That would have been 16. So the alkane formula is this. If it were an alkene, it should have had the formula of C7H 16, which is also heptane, right? We also know the name for it, it's heptane. So why is this not an alkane? Why is this not an alkane? Because it does not fit the general formula. It does not fit the general formula for alkenes. तो एग्जामिनर फिर अगला सवाल अक्सर पूछता है, सर तो अगर इसका कोई एल्केन होता तो उसका फॉर्मूला क्या होता है? C7H16। खत्म। Sir, this was an introduction to alkanes. Alkanes is almost finished. Now we are going to look into the trends in physical properties. अच्छा जी, we are going to look into the trends in physical properties. Sir, please scroll up. हाँ जी, शाबाश 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 शाबाश। हाँ जी, done. What was the question? The question was, is this an alkene? That was the question. Is this an alkene? यही सवाल था। आगे बढ़े। अच्छा जी, कल हम केमिकल रिएक्शंस करेंगे सारे इंशाल्लाह। एल्केन्स कल मुक जाएगा। एल्केन्स पे 3 क्लासेस हमेशा लगती हैं, फिर आगे हर फैमिली पे एक क्लास लगती है, क्योंकि एल्केन्स में बेस बनाना होता है, उसके बाद सारा हलवा है। कुछ भी नहीं है आगे। आगे बढ़े। चलो जी, ट्रेंड्स इन फिजिकल प्रॉपर्टीज सर। स्टेट, then you have like density, then you have too easy, I love it, that's awesome. Then I have like your mass होगा, फिर होगा आपके पास साइज कर लेते हैं, फिर आपके पास कर लेते हैं, ओहो, फिर आपके पास कर लेते हैं बॉइलिंग पॉइंट, फिर उसके बाद हम आपके पास कर लेते हैं फ्लेमेबिलिटी, ओहो, फिर उसके बाद हम आपके पास कर लेते हैं, इधर नीचे कर लेते हैं वॉलेटिलिटी, और इधर हम कर लेते हैं विस्कोसिटी। लिख लें बेशक है, लिख लें, पे देखते हैं। आई एम गोना राइट द alkanes for you. I'm gonna write the alkanes for you. So that's CH4, C2H6. Now you guys can also write it. देखिए, writing the formula for alkenes doesn't mean you always go to your brain and say, oh, CnH2n plus 2CnH2n plus 2CnH2n. It's pretty easy to write it. You see, you have 3 carbons, hydrogens will be twice the number of that. That's 6 plus 2, that's 8. C4, your 4 carbons, hydrogens will be twice the number of that. 8 plus 2, that's 10. मतलब डायरेक्ट डायरेक्ट करें। पहले ये लिखेंगे CnH2n plus 2, the n represents the number of carbon, so if you have 3 carbons, put 3 here and then put 3। बड़े हो जाएंगे यार, क्या हो गया? Sorry, sorry guys, sorry, sorry, sorry. Then you have 5 carbons, hydrogen will be twice the number of that plus 2, that's 12. You have 6 carbons, hydrogen will be twice the number of that, which is 12 plus 2, that's 14. And you know it, you literally know it. I proved it to you. I literally proved it to you in the above situations. If you want a proof for it, I've shown it. So the general formula is CnH2n plus 2, and it will be applicable on all alkenes. All alkenes will fit this general formula. है? अच्छा जी, शुरू करें जी, शुरू करें जी, शुरू करें। 2 मिनट का काम है, 2 मिनट का काम है। अच्छा जी, स्टेट, what will happen to the state as the number of carbons increases? That's what we mean by trends in physical properties. So these are some physical properties for which you need to know the trend when the number of carbon increases. What you need to understand is, as the number of carbons increases, the size of the molecule increases, right? CH4 is smaller compared to C2H6, compared to C3H8, compared to C4H10, C5H12, C6H14, right? Even if I make the structures right here, this is CH4, this is like, ethane, this is your beautiful propane, that's your beautiful butane and whatnot, right? So what you realize is, as the number of carbon increases, the size of the molecule increases. And as the size of the molecule increases, you'll realize obviously there are millions and billions, not millions, there are billions and trillions of molecules, right? You've studied moles and stoichiometry. So if I say you have 1 mole of methane, you understand that you have 6.02 into 10 raised to the power 23, which is effectively 602 sextillion molecules, right? तो बहुत ज्यादा molecules होते हैं, तो इनके बीच में interactions होती हैं. All these molecules have interactions between them. And what is this interaction called? This interaction is called what? Intermolecular forces of attraction. Remember chlorine gas के बीच में intermolecular force of attraction. So you guys tell me something. Logically speaking, when the number of carbons increases, obviously the size of the molecules start to increase. And if the size of the molecules start to increase, what will happen to the intermolecular forces of attraction? The intermolecular forces of attraction increases obviously, and which state has the highest intermolecular forces of attraction? Solids, liquids, or gases? Obviously no, sir. Gases have the weakest intermolecular force of attraction. But as the intermolecular force of attraction starts to increase, you're going to go from a gas to a liquid and then to a solid. So you guys tell me, logically speaking, what will happen to the state as the number of carbon increases? So you say, hey, as the number of carbon increases, the size of the molecule increases, and when the size of the molecule increases, the IMF increases or strengthens, sir, and therefore the state changes gradually from gaseous state to liquid state and then to solid state. And it is so easy to even visualize this, sir. Methane is the gas that comes to your home. So if this were a solid, why would then it wouldn't be the gas that comes to your home, right? Solid तो इसीलिए तो नहीं आता क्योंकि methane gas is not a solid, it's a gas. That's why I'm saying methane gas, right? It's the main constituent of natural gas. So what will happen to the state as the number of carbon increases? That's the trend. The size will increase, the IMF will increase, and then the state will change from a gaseous state to a solid state. Now you guys tell me, do solids have a higher density or do gases have a higher density? Again, we're talking about trends. There might be certain anomalies in it. You'll study those anomalies in A levels. लेकिन मुझे एक बात बता, ट्रेंड की बात करते हैं, सॉलिड की ज्यादा डेंसिटी होती है, गैसेस की ज्यादा डेंसिटी होती है? जाहिर सी बात है सॉलिड्स की ज्यादा डेंसिटी होती है. सो एज द नंबर ऑफ कार्बन इंक्रीजेस, व्हाट विल हैपन टू द डेंसिटी? What will happen to the density? Obviously the density is going to, yes, the density is going to increase. Thank you very much. बिल्कुल अलीम, ज़रूरी तो नहीं है कि वो स्टेट चेंज करेगा. अगर आप एक सॉलिड एल्केन को हीट करना शुरू कर दें, तो हो सकता है वो लिक्विड हो जाए और फिर हो सकता है वो गैस भी हो जाए, तो वो तो हो सकता है. लेकिन एल्केन्स को जब आप हीट करते हैं, दे अंडरगो कंबस्शन कज देयर फ्यूल्स. तो वो आपको मैं किसी दिन सिखा दूंगा, हैं? आगे जाके पढ़ेंगे. अच्छा, व्हाट विल हैपन टू द मास? बताएं जी, मास को क्या होगा एज द नंबर ऑफ कार्बन इंक्रीजेस? मुझे बात बताएं, ये सारा हम कार्बन की इंक्रीज के साथ बात करें. मास को क्या होगा? सी, लुक एट दिस, इट्स सो इजी. If the number of carbons are increasing, the total number of atoms bonded are also increasing. The total number of atoms are also increasing, right? Atoms. But अब मुझे बताएं, इसका मास निकालने क्या है? 12 plus 4, that's 16. Can you guys take out this number? 12 times 2 multiply plus 1 times 6. So you guys understand that if the number of carbons are increasing, the number of total atoms are also increasing. And if the number of total atoms are increasing, this means that the mass is obviously also going to increase. And I've proven it to you. This has a mass of 16. This is 12 times 2 plus 6. This is 12 times 3 plus 8 and whatnot, right? So this means that CH4 will be a gas because of less intermolecular force, because of weaker intermolecular force of attraction. हाँ? तो सर ये इंक्रीज है, ये इंक्रीज है. अच्छा, आपसे पेपर में रीजनिंग नहीं पूछ रही, आपसे पेपर में रीजनिंग सिर्फ इस चीज का पूछ सकता है. मैक्सिमम इस चीज का पूछिए, ये बाकी सारी रीजनिंग आपसे नहीं पूछता, ये मैं आपको बता रहा हूं कि लॉजिकली आप साउंड रहो। अच्छा, साइज, व्हाट विल हैपन टू द साइज, कम ऑन यार, मतलब साइज को क्या होगा, और कार्बन बढ़ रहे हैं, साइज बढ़ रहा है, ये देखिए शो हो रहा है, देखिए नजर दिख रहा है, तो रट्टे मारने की कोई जरूरत नहीं होती, साइज इज ऑल्सो इंक्रीजिंग एज द नंबर ऑफ कार्बन। बॉइलिंग पॉइंट को क्या होता है बताएं जी, व्हाट विल हैपन टू द बॉइलिंग पॉइंट, शाबाश। हाँ जी, वाई, अब ये सवाल पैदा होता है, ये एग्जामिनर पूछता है, वाई आर यू सेइंग दैट द बॉइलिंग पॉइंट इंक्रीजेस, यू ऑल आर सेइंग दैट द बॉइलिंग पॉइंट इज गोना इंक्रीज, वाई। अब खुद खुद लॉजिकली, यस, हरीम इज एब्सोल्युटली राइट, अनस इज एब्सोल्युटली राइट, अलीन इज एब्सोल्युटली राइट, एवरीबody is right, sir. Why is the boiling point going to increase? Because you realize if the number of carbons increases, obviously I told you guys before that the intermolecular force of attraction increases, and so if the intermolecular forces of attraction increases, more energy is going to be required to break the bond, so more energy is required to boil it, is required to break bonds and boil it, huh? To boil it, aka break bonds, yeah? Breaking bonds. Old bonds must be broken for new bonds to form. Yeah? खत्म। तो ये एक सवाल पूछ सकते हैं, इसका रीजनिंग आपसे पूछ सकते हैं, सो सर बॉइलिंग पॉइंट भी इंक्रीज हो, सारी गेम आईएमएफ की है। फ्लेमेबिलिटी, व्हाट विल हैपन टू फ्लेमेबिलिटी, यार सिंपल सा कॉन्सेप्ट है, आर गैसेस मोर फ्लेमेबल और आर सॉलिड्स मोर फ्लेमेबल, बताएं जी, रट्टा मारने की जरूरत नहीं है, गैसेस ज्यादा फ्लेमेबल है सॉलिड्स। अच्छा वैसे सोचे, जस्ट फॉर वन, जस्ट फॉर द सेक ऑफ यू नो, मतलब लॉजिक की जिसने आत्मा रुली होती है ना, लोग कहते हैं केमिस्ट्री में लॉजिक क्या है, लॉजिक से चल रहे हैं, कैन समबडी टेल मी, जिसको ना मतलब बिल्कुल लॉजिक की एक दो की हुई है, मुझे आप एक बात बताएं, आपके घरों चूल्हों में क्या आता है, आपकी चूल्हों में गैस आता है कि सॉलिड आता है, आपकी चूल्हों में गैसेस आते हैं, विच स्टेट कम्स इन योर चूल्हास, इन योर स्टोव्स, गैस आते, क्यों आते, कभी सोचा है क्यों आते, सॉलिड क्यों नहीं आता, लिक्विड क्यों नहीं आ रहा होता है, गैस क्यों आ रहा होता है, इसीलिए आ रहा है because gases are more flammable, gases are more flammable than solids, इसलिए तो गैस आते हैं यार, वरना सॉलिड, हुकूमत का दिमाग खराब है, आप सबको सॉलिड दे देता। अच्छा आप सोचिए गैसेस क्यों फ्लेमेबल होते हैं सॉलिड, उनकी पहली से इतनी ज्यादा एनर्जी होती है यार, दे ऑलरेडी हैव सो मच एनर्जी, यू स्टडीड दिस इन स्टेट्स ऑफ मैटर, ये बातें आपने स्टेट्स ऑफ मैटर में पढ़ी है कि गैसेस मूव रैंडमली एट हाई स्पीड्स, एट हाई स्पीड्स दे हैव द हाईएस्ट एनर्जी, उनकी वैसे एनर्जी उनकी इतनी ज्यादा होती है, इसीलिए इफ यू टेक परफ्यूम, परफ्यूम के पीछे लिखा होता है हाईली फ्लेमेबल, गैसेस आर ऑलरेडी हाईली फ्लेमेबल, राइट, सो व्हाट यू रियलाइज इज दैट द फ्लेमेबिलिटी इज गोइंग टू इंक्रीज और डिक्रीज, यू आर गोइंग फ्रॉम अ गैसियस स्टेट टू अ सॉलिड स्टेट, अ गैसियस स्टेट टू अ सॉलिड स्टेट, द फ्लेमेबिलिटी शुड एब्सोल्युटली डिक्रीज। खत्म। Volatility. What is meant by volatility? Volatility is the tendency of a substance to evaporate at normal temperatures. Huh? Is the tendency, I'll write it, the tendency, tendency में एक ए आता है, दो ए आते हैं, सॉरी ए आता है कि ई आता है, tendency, sorry, it's the tendency of substances to evaporate at normal temperatures, टू एवेपोरेट एंड फॉर्म ए गैस, राइट, ऑब्वियसली। अब मुझे एक बात बताएं, नहीं नहीं गलत गलत, यही एब्सोल्युटली रॉन्ग, यही आई थिंक इट डिक्रीजेस डाउन द सीरीज, ये कोई रिएक्टिविटी सीरीज नहीं है, वी आर टॉकिंग इन टर्म्स ऑफ इंक्रीज इन नंबर ऑफ कार्बन, यू इवन इफ यू सेड डिक्रीज यू विल से इट डिक्रीजेस एज द नंबर ऑफ कार्बन इंक्रीजेस, तो ये कार्बन की इंक्रीज होने के साथ ये सारी ट्रेंड्स कनेक्टेड है, सीरीज मीरीज कुछ नहीं है भाई, फैमिली है एक। अच्छा जी, इट्स फाइन चिल, व्हाई डू सिंग सॉरी, चिल। अच्छा मुझे एक बात बताएं, वॉलेटिलिटी क्या होती है, हैव यू एवर बीन टू अ पेट्रोल पंप, हैव यू एवर बीन टू अ पेट्रोल पंप, if you've ever been to a petrol pump, you must have, you know, you must, some people are also addicted to it, you must have smelt petrol, it smells really good, some people are also addicted to it। केन्या जब मैं गया था ना, I went to केन्या कुछ सालों पहले, तो केन्या में the जो उधर के लोग थे, some of them, most of them were also, no, not most of them, but you know, some of the locals were addicted to samad bond। Do you know what samad bond is? Samad bond is the glue। तो समद बॉन्ड को वो एडिक्टेड थे। अच्छा ये कैसे उनको ये स्मेल आती थी, वो इसलिए आती बिकॉज पेट्रोल समद बॉन्ड दे आर हाईली वॉलेटाइल, which means if I'm saying they're volatile, they have a very high tendency to evaporate into it। इसीलिए तो कहते हैं पेट्रोल पंप्स में don't light a cigarette at petrol pump, don't, you know, don't in any case whatsoever, don't even use your phone at the petrol pump, because there might be some static charge which can which can be caught by those petrol molecules in the air, because petrol is highly volatile and that may cause the entire petrol pump to to blast, right? और आजकल आपने देखा होता है हर बंदा फोन शोन इस्तेमाल करता हो, तो उसकी रीजन ये है कि उन्होंने अर्थिंग की होती है। पेट्रोल पंप में बड़ी हाई लेवल की अर्थिंग होती है, जो आपको फिजिक्स की टीचर बताएंगे। समद बॉन्ड बिल्कुल सॉलिडिश लिक्विडिश है, लेकिन इट्स स्टिल वॉलेटाइल, उसका वो सॉलिडिश नहीं होता, इट्स लिक्विड। समद बॉन्ड लिक्विड है लेकिन वो उससे वॉलेटाइल है, इट हैज अ वेरी हाई टेंडेंसी टू एवेपोरेट। नाउ इट्स ए लिक्विड, नॉट अ सॉलिड, लिक्विडिश फॉर्म में होता है, ठीक है जी। अच्छा, आप मुझे एक बात बताएं, गैसेस ज्यादा वॉलेटाइल हैं कि सॉलिड ज्यादा वॉलेटाइल है? अब खुद देखें जरा। Substances to evaporate, gases have already been evaporated, gases की volatility क्या देखनी है, it's already evaporated, and liquids are more volatile or solids are more volatile? Are liquids more volatile or are solids more volatile? Obviously liquids are more volatile than solids. So what will happen to the volatility as the number of carbons increases? The volatility is gonna decrease. Thank you very much. The volatility decreases because gases are already in the air. So what do you mean by volatility? Liquids are more volatile than solids. सवाल पैदा होता है, why are liquids more volatile than solids? Why? अच्छा, मुझे बात बताएं, particles, when can they escape? When can they escape? Allah Ta'ala or the universe has this beautiful mechanism of intermolecular forces of attraction, which is a gluing force, right? So there's a gluing force between all particles which holds them to some extent. Now, when does a particle escape? It escapes when it overcomes the gluing force, when it overcomes the intermolecular force of attraction. Now you guys tell me, does a liquid have a stronger intermolecular force of attraction, or does a solid have stronger intermolecular force? Obviously solids have stronger intermolecular force of attraction. That's why it's difficult for a particle to escape, and it's difficult to have a tendency in which the particle can easily escape into the air. So why are liquids more volatile than solids? Because they have a weaker intermolecular force of attraction compared to solids. So the particles can escape relatively easily compared to particles in the solid, right? So आपको ये रीजनिंग नहीं पता होनी चाहिए, रीजनिंग सिर्फ बॉइलिंग पॉइंट की आनी चाहिए थी बस, और ये स्टेट की आनी चाहिए थी। बाकी रीजनिंग में आपको दे रहा हूँ कि लॉजिकली सोचो यार, ठीक है। एंड व्हाट विल हैपन टू विस्कोसिटी? सवाल पैदा होता है विस्कोसिटी सर होती क्या है? व्हाट इज मेंट बाय विस्कोसिटी? विस्कोसिटी लिटरली मींस स्टिकीनेस, बट स्टिकीनेस में वाई आता है, आई आता है, आई थिंक इट्स आई नॉट वाई। यार मेरी स्पेलिंग बहुत खराब हो गई। It's stickiness, right? Stickiness कह सकते हैं, thickness कह सकते हैं, but that's the layman, definition or the layman terminology. Can you guys tell me? Yes, in science, viscosity is the resistance. If you want to be more scientific, it's the resistance to flow. It's the resistance to, अच्छा इसका मतलब क्या है? Stickiness या thickness या असल definition resistance to flow. What does this mean? Sir, tell me something. Is honey more thick or is water more thick? Is honey more thick or is water more thick? Honey is more thick than water. Honey is more thick than water, right? Honey is more thick than water. So can I say, is honey more resistant to flow or is water more resistant to flow? कौन सा आसानी से फ्लो करते हैं? पानी आप पेंगे आसानी से फ्लो करते हैं, हनी इज स्लो, राइट? सो विच वन इज मोर रेजिस्टेंट टू फ्लो? ऑब्वियसली हनी इज मोर। ओ क्या हो गया यार, वाटर वाटर क्यों लिख रहे हो? वाटर क्यों नहीं? आप पानी को बहलाएं और हनी को बहलाएं, पानी बहुत जल्दी में बह जाते हैं और हनी जो है वो आहिस्ता 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 करके जाता है। सो फ्लो, विच वन इज मोर रेजिस्टेंट टू फ्लो? कौन सा फ्लो को रेजिस्ट करते हैं ज्यादा? इट्स हनी यार, इट्स हनी। हनी इज मोर थिक. So the layman term for viscosity is just thickness, right? But in science, we see it's the resistance to flow. Or why something more resistant to flow? Because it's more thick, right? It's more, the particles, the intermolecular force of attraction are stronger. So it is resisting that force. It's resisting that force. So now you guys tell me, गैसेस आसानी से फ्लो करते हैं कि लिक्विड्स आसानी से फ्लो करते हैं कि सॉलिड्स आसानी से फ्लो करते हैं? Which one flows easily? Gases, liquids, obviously gases, and then liquids, and then these solids are very resistant to flow. Solids are very resistant to flow. Why are solids very resistant to flow? बात जाती 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 किधर आती है? Intermolecular force of attraction pe. So if I'm saying solids are more resistant to flow, why? Because they have strong intermolecular force of attraction which holds those particles in place. वो कहते हैं नहीं flow करना, नहीं flow करना. That's why in chapter number 1, remember I taught you that was the most important chapter. In chapter number 1, you learned that solids, they vibrate about a fixed position. They can move. They're very resistant to flow. Why are they resistant to flow? Because they have the strongest intermolecular force of attraction. So logically speaking, will solids be more resistant to flow, or will liquids be more resistant to flow or gases? Obviously, solids are the most viscous substances. So what will happen to viscosity? The viscosity will increase. Did you need to know this much logic? Absolutely not. नो नो मरियम क्यों डिक्रीज क्यों होगी? सॉलिड ज्यादा विस्कस है या लिक्विड ज्यादा विस्कस है या गैस ज्यादा विस्कस है? खुद सोचे यार. हनी और गैस. नहीं नहीं नहीं, गलत गलत गलत. मरियम, viscosity is the resistance to flow. Can gases flow more easily or can solids flow more easily? Can gases flow? Oh yeah, gases can flow easily. Solids can't flow easily. Gases can flow easily because of the weakest intermolecular force of attraction. What happens when the number of carbons increases? The state is changing from gas to solid. So as the number of carbons increases, what should happen to the viscosity? You're going from a gaseous state to a solid state. So you're going from something which is less viscous to something which is very, very more viscous, right? Yes, it increases because viscosity is the resistance to flow and solids are the most resistant to flow. Sir, ये आपकी कहानी थी. And now one more thing, I will not teach this in all the other families, but this applies to every single family. Why does this apply to all families? Why does this apply to all families that you study? Why does these trends apply to all families? Why? Because in all families, what do you do? When you talk about the trends, the number of carbons increases. When you talk about the trends, the number of carbons. So in every family, when the number of carbons will increase, sir, can you zoom out a little here? In every family, when the number of carbons increase, be it alkanes, alkenes, alcohols, carboxylic acid, the state will change, the density increases, mass, blah, blah, blah. Everything will be like this in every family because you're talking in terms of the number of carbons increasing, right? जैसे जैसे कार्बन्स बढ़ते जाएंगे और एटम्स आते जाएंगे, mass बढ़ता जाएगा and what not, right? So I will not be teaching this in any other family because यही है. हर फैमिली में यही है, इसलिए मैंने ये बहुत डिटेल में समझाया. हर फैमिली के लिए यही जनरल ट्रेंड है, यही ट्रेंड्स इन फिजिकल प्रॉपर्टीज हैं. बस 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 बहुत हो गया, बहुत हो गया. कल कल इंशाल्लाह के कल एल्केन्स का आखिरी दिन है, मुक गया. अच्छा, Abdullah Singh sir, please send the notes. Kiddo, I will send you the notes, but if you don't write it, if you don't, you write it on your own when I'm teaching you these and, when I'm making you guys solve examples and you don't do it on your own, things are going to be very, very different and very, very difficult for you guys. जब तक अपने हाथ से ना किया हो, कुछ भी नहीं होता है. अपने हाथ से करना है, ठीक है? चलो guys, bye bye. Ciao, ciao. Allah Hafiz. Sir, the color of these notes is so much prettier. Thank you, thank you. I know. Bye, ciao. Bye.